Um, Hi everyone. So today is the last lesson of the Polynomials unit. Yay! Just to recap, last lesson we worked with trinomials and practiced factoring and expanding expressions. So today we're going to continue on factoring, but we're also going to look at a few more methods for factoring trinomials. So last week we didn't really pay a lot of attention to trinomials that had the form. Oh no, this is a typo. Of the form ax squared plus bx plus cx, where a wasn't equal to 1. But we're going to kind of go into more depth about that today. We're also going to take a look at some special polynomials, which are just polynomials that have unique properties, I want to say, or they have a special method for factoring them. And then we're going to kind of do a big overview of this unit, because we are done after 3 lessons. So what I'm going to start off with first is factoring trinomials by grouping. So over here, you see I have a polynomial expression with 4 terms. Notice how the middle 2 terms can be simplified, so they can be added together. But in this case, we don't want to do that because we want to group them. And if we simplify the middle expressions, it'll actually make it harder for us to factor. So this is how we factor by this method called grouping. What it looks like is we're essentially going to group, we're going to group this 4-term expression into little groups of 2. So let me just underline these 2 groups. I'll group the first 2 together and the last 2 together. So grouping these 2 together will make it kind of easier for us to deal with, not as many terms to work with. So let's take a look at the first group that we've made, 6x squared plus 3x. What we want to do is we want to try to find a common factor in both of these terms and take it out. So in this case, 6x squared plus 3x, you can kind of look at factor it by inspection. Notice how there's a 3 and then a multiple of 3, and also there's an x and an x squared. So what we can take out is we can actually take out a 3x from both of these. We can take it out, which leaves, I'm going to put the remaining stuff in the brackets, which leaves, so when we take out the 3x, we're essentially dividing 6x squared by 3x, which leaves 2x plus, and 3x divided by 3x is 1. So this is what we're left with. For the next group, I should rewrite this so I leave myself more room for the other side. 3x squared, 2x plus 1. Okay. Now for the next group, we're going to do the same thing. We're going to find a common factor that both of these terms have and take it out. In this case, we can't take out an x because 4 doesn't have an x beside it. But we can take out a 4 from both of these. So 8 divided by 4 leaves, 2. And then we have to keep the x as well because the x never got divided out. And then we have 4 divided by 4 is 1. Now notice how these 2 terms, let me grab a different color. These 2 terms, very bad at underlining, are the same. Yay. So what we can do from here is we can actually factor these 2 terms out of this expression. This entire expression, we can take these 2 terms out because they are also considered a common factor since they're multiplying this. So let's do that. I will grab a, so once we take these 2 terms out, 2x plus 1, what are we left with? We are left with these. Let me grab a different color. We're left with these remaining terms, which we can put in another bracket. So this is what happens when we factor it by grouping, and it's pretty convenient. It might look like it has a lot of steps at first, but once you get used to it, it'll go by really quickly. Like you'll look at a question, bam, and then factor it. So let's try another example. Down here we have another, we have another trinomial, and the reason why it's called trinomial, even though it looks like it has 4 terms, is because these 2 middle terms can be simplified. So we're going to still call it a trinomial. This expression can also be grouped. Let's do that. So we have in the first group 12x squared plus 9x. We can do this by inspection. We can take out a 3 from both and an x as well. So we can take out a 3x from both. 3x. And what we're left with is when 12x squared gets a 3x taken out, it's left with a 4x, because 12x squared divided by 3x is 4x. And when 9x gets a 3x taken out, it's left with 3. And we can always, something to know, if you're writing a quiz, you're not sure about your final answer, you can always double check by distributing the 3x back into each of the terms. So if we re-multiply the 3x back in, would it equal the original expression? Let's try. 3x times 4x is equal to 12x squared, and 3x times 3 is equal to 9x. So this is correct. That means we did factor it correctly. So that's just a tip. You can always double check. All right. And now for the other side, this time, what's different is that we see these negative signs, right? But don't forget, we can actually factor them out, because we always want to factor out negative signs from the expression. So let's first deal with the 8x minus 6. So what can we factor out from here? Well, it doesn't look like we can factor out anything too big, so maybe just a 2. We can only factor out a 2, because that's the only common factor these have. So let's do that. We got a 2, but remember there are negative signs in front of these, so let's also take out the negative sign as well. I'm going to factor out a negative 2, and what's left is 8x divided by negative 2 is equal to 4x. And then negative 6 divided by negative 2 is equal to positive 3. Notice again how these remaining factors are the same. In any trinomial that is factorable, your teacher will make sure that it can be factored. So the stuff left inside will always be the same. Always will. Let me write this down. Any trinomials of this form. I guess I should also say any factorable. Let me just durable. Any factorable trinomials of this form will have the same leftover binomial. What I mean by this is just if a trinomial is factorable, once you group it, the leftover stuff, once you take out the factor, will be the same on both groups. So yeah. Now you might be wondering, well, what happens if I flip the middle? Like if I put negative 8x in front and 9x behind the negative 8x. So I group the 9 with the 8. Oh, sorry, the 12 with the 8 and the 9 with the 6? Well, we're going to take a look at those soon. Anyways, we got off track. Let's get back into our factoring. Once we've taken out these common factors, we can now take out the 4x plus 3. And with the remaining 3x minus 2, we can also group those two together. Not group, but put them in the same binomial. And with that, we're done. Yay, we're done. That's what it looks like once it's been factored. And once again, we can always double check by re-expanding the entire thing, although I don't know if you might not have enough time for that because it is quite a troublesome, but we can re-expand by multiplying using FOIL, so first, outside, last, to make sure that the expanded form actually is the original, is the same as the original. Actually, let's do that so you guys can see what I mean. So let's go with the method of FOIL first. So 4x times 3x is equal to 12x squared. Outside, so 4x times 2 is equal to 8x. And then inside, 3 times 3x is equal to 9x. And then outside, last, 3 times 2 is equal to 6. Oh, I forgot that this was actually a negative. That's why I was like, wait, but up here it was a negative 6. Why am I getting a positive 6? That is because I wrote it wrong. Let me just grab an eraser. This 2 was actually supposed to be negative, which changes this value and this value. So now they are negative. All right, so that means we did it correctly. When we re-expand it, our expanded form is the same as the original. Expand, I don't even know if re-expand is a proper word in the dictionary. So I'm gonna put it in, what are those called? Quote marks, quotation marks. We want to re-expand to check final answer. All right. So this is correct. Let's move on. So now we're going to be factoring a trinomial that has the form ax squared plus bx plus c using the method of decomposition. So what the method of decomposition is, decomposition usually connotates a feeling of like, breaking down, right? So I don't know if you're really into composting or anything, but when you compost, you often call the apple that you threw out, over time, it kind of breaks down and you call it decomposing. Well, in factoring, it's kind of like that. We want to break down the trinomial into smaller bits. So over here, what I've written was the method of decomposition is basically splitting the value of b, which is this. I'm going to switch colors, which is this, into two integers that have a product of a times c and a sum is, well, b. So in the case of this, let's take a look at the first example. Our b value is 7. b equals 7. Our a value is 2. Our c value is 6. So using the method of decomposition, what we want to do is we want to split b into two integers. So let me kind of erase this and rewrite it on the side. A is equal to 2, b is equal to 7, c is equal to 6. What we want to do is we want to split b, so split 7 into two integers. And what do those two integers have to do? Well, when we multiply those two integers together, they have to have a product of a times c. So in this case, what is a times c? Well, ac is 2 times 6, which is 12. Did I do that correctly? Yes. So we want to find a value, we want to split 7 into two integers that will multiply together to give us 12 and add together to give us 7. How can we do that? Well, it's really just trial and error. So let me teach you. A smart way to do this is not just to pick two random numbers in the universe, because that would just not be realistic. Wow, I just switched colors like 3 times. Let's take a look at 12. We want to, since we know that those two integers that we're looking for have to have a product of 12, what we can do is find factors of 12. So let's just name a bunch. So 1 and 12, do they add up to 7? No, so we have to keep on going. 2 and 6, do they add up to 7? No. Let me just put an X. 3 and 4, do they add up to 7? Yes, they do. So these are the integers that we are looking for. So now we can bring these two integers into our equation. Let's see, what color? Orange. Let's split 7 into those two integers. So 7x becomes 3x plus 4x. Do you agree that 3x plus 4x is equal to 7x? Well, 3 plus 4 is definitely 7. X plus x, well, you know, if x is just kind of like, x is just there to show us or kind of be a substitute for an unknown integer. Let me move these values over a bit. All right. So what we have here, now we're just gonna kind of bring down the other values as well, the other terms. I'm gonna bring down 2x squared. I'm gonna bring down 6. All right, so now we have a form that we're familiar with. We were looking at this in the last slide when we were factoring by grouping. So now that we've decomposed this trinomial, we can now group to figure out how to factor it. So let's try. I want to group the first two together. Let me grab a different color. Yellow. Group the first two together. Okay, you cannot see this very well. I'm going to group the first two together. That is also not very clear. Okay, maybe I should just stick with the black. Red. I'm going to group the first two together and the last two together. And then I'm going to factor out a common factor. So what numbers with an S, I guess also variables, is common in both of these? Well, unfortunately, there are none. So 2 and 3 don't have any common factors, but x is in both of them. In fact, 2x has 2 x's. So we can take out an x, even though we can't take out anything else. So we're going to leave the rest in there. In the second one, what can we take out? Well, these are both even numbers, so we know we can definitely take out 2. But can we take out x? Well, no, 6 doesn't have x. So we can only take out a 2 in here. Positive 2. We can take out a positive 2. So remaining is x. Oh, sorry, not x. 2x plus 3. And would you look at that? These are the same again. Hooray! That means we know that we factored correctly. So what we're left with, if we take out the 2x plus 3, is 2x plus 3 times x plus 2. And that is our final factored form. Our final form. Ha ha ha. If we want to check, we can just remultiply or redistribute every value and see if our expanded value is the same as the original question. I'm going to put it in a box to make it more clear. All right, next. I'm going to kind of bring it over. Select. All right. Over here, it's kind of like the same type of problem. We're given 6x squared plus 17x minus 3. So once again, let's kind of write down all of the values. What is a in this expression? A is 6. A is equal to 6. And b is equal to 17. And now what is c? C might be a bit misleading. What most people might think at first is 3, but that's not all because there's actually a sign on 3. You can't ignore that negative sign. Don't ignore the signs. So c is actually negative 3, not just 3. So what is AC then? Well, AC is 6 times negative 3, which is equal to negative 18, sorry. Negative 18. This is different from, yeah, that's why it's really important to be aware of your signs. If it had been a positive 3, then our AC would have been 18, which would have been a completely different expression. So now same thing, we want to find factors of negative 18 that add up to positive 17. Now how is this possible? Well, we're just gonna have to try. Remember that a negative product always has one of its factors being negative and the other one of its factors being positive, because a positive times a negative is a negative, right? So what we can do is we can kind of go through the factors of 18. So what comes to my mind right away is 3 times 6, negative 3 times 6. Does that add up to 17? No. But note that we can also have put negative 6 and 3 because both of these multiply up to negative 18. Multiply to negative 18. But none of these work. So let's go in order, I guess, then. So we have negative 1 and 18. Does that work? Well, negative 1 plus 18 is the same as 18 minus 1, which is 17. And that is what we're looking for. So that does work. Hooray, we don't have to go any further. So 17 can be broken down into negative 1x, which is the same as negative x, and positive 18x. Then we just bring down the rest of the terms. So 6x squared and negative 3. It's so cute. All right, and now we can group. Let's group together 6x squared and negative x, as well as 18x and 3. So 6x squared, we can't, well, since this has a negative x, we can't exactly take out anything other than an x. So yeah, we can just take out an x, which leaves us with 6x minus 1. And then in 18x minus 3, we can take out a 3. Yes, because 18 is 3 times 6, so we can take out that. 3, and what we're left with is 6x squared minus 1. And surprise, they are the same. Once again, let me underline it. Same. I don't know why it started defaulting to white to underline things, but it's not convention or anything. Now let's just bring over these like terms, like binomials here. Not like terms, sorry. These, we can factor out the 6x minus 1. And then what remains is x plus 3. And that is our factored form. Once again, we can always double check if you want to make sure your answer is correct. But earlier I mentioned, I asked you all what would happen if I switch these values around. Like what would happen if I put 18x here first and then negative x after 18x? Well, the short answer is it's basically going to be the same but flipped. So let me show you. I'll just erase this. What it's going to look like. So I'm going to recopy the entire equation on this side. Right beside it, let's draw a line to differentiate. So what I have is 6x squared plus 18x minus x minus 3. So what I've done here is I've just flipped the position of the 18 and x. So if we group it this way, well, what we have here, we can take out a 6x, and what we're left with is an x, and a 3. Over here, what we can take out is a negative 1. What we're left with is an x plus 3. So essentially, it's just this, but flipped the other way. So once we take out the common factor, we're left with x plus 3 times 6x minus 1, which is basically the same thing, except flipped around. So yeah, it doesn't really matter which way you put it. You don't need to put the bigger number first or anything. They'll give you the same answer. Okay, moving on. Special polynomials. So they're not like special isn't a technical term or anything. That's why I put it in quotation marks. But what these describe are basically polynomials that don't fit into the form ax squared plus bx plus c, which is kind of the form that we were talking about earlier, you know, these ones. So, or they can also have like peculiar qualities. So let's kind of explore some of them. What we've talked about last week was difference of squares. So here's a bit of a review. Difference of squares are basically polynomials in this form. Oh, I'm using green now. Okay. A squared minus b squared is equal to the binomial a plus b times a minus b. So over here, I have a few examples that we can quickly run through. It shouldn't take too long since it is, you hopefully have memorized your squares. I'm wasting so much time deciding colors. I don't know. Wow. I'm just going to go with black so I can. All right, so first we have t squared minus 144. 144 is the square root of, or not the square root, sorry, 144 is 12 squared. So what we can do is, we know that it's going to be in this format, so I'm just drawing it out. We can just put it in the numbers. Bam. T plus 12 times t minus 12 is equal to t squared minus 144. This is our final answer. It was that easy. Next, 36. M squared minus 36. So 36 is equal to 6 squared. So hopefully you write this down faster than I did. M plus 6 and m minus 6. All right, moving on. Told you these were going to be quick. This one looks a bit different, but it's essentially the same idea. X plus y and x minus y. All right, next. Over here, it's basically the same thing. It's like in this form directly. We've substituted a with n, and we've substituted b with 8. So same thing, just n plus 8 times n minus 8. All right, that's it. Great review. Moving on. Sometimes differences of squares will have a common factor, and when we're doing when we're trying to factor any polynomial expression, we always want to take out the common factor first before we, check for differences of squares or start decomposing it or grouping it. We always want to take out any common factors. So let's take a look at example A. Over here, 2a squared minus 50. What factors do they have in common? Well, a really easy way to kind of remember this is if both of the numbers are even, then they'll definitely have a 2 in common for sure, because 2 is a factor of every even number. You can take a 2 out of any even number in the universe. So let's take that out, because that seems to be like the only factor that's in common with these two terms. 50 doesn't have a, so we can't take out an a, and a doesn't have, a number. So we're left with a squared minus 50. But that's not all, because notice this. Can it be factored? Well, it doesn't look like it. So I guess this is the final answer. All right, moving on. Over here, we have 3x squared minus 12y squared. Well, this should pop out right at you. You can take out a 3, of course. We're left with x squared minus 4y squared. Oh my gosh. 4y squared. Don't forget the y squared. Can we factor this any further? Well, actually, we can, because this is a difference of squares. You see this minus sign, you see this square, you see this square. We can definitely take these out. So let's go back to, remember that a squared minus b squared, it can be factored into the form a plus b times a minus b. So over here, a is x and b is 4y. So let's do that. Once we factor this fully, it becomes x plus 4y times x minus 4y. Don't forget the 3. The 3 still stays. Don't take the 3 out. And that's it. All right, so now we're going to take a look at some more, I want to say complex, but it's not really that complex. They're just different. Differences of squares. So a reminder from last week, I've kind of told you about this briefly, but a and b can also represent polynomials. So you can put an entire polynomial expression inside a. Seriously. It can get very, very messy sometimes if those polynomial expressions are long. But over here, I've given you a relatively friendly example. You have x to the power of 4 minus 16y to the power of 4. So over here, you can actually think of this as, what has a been replaced by? Well, let a be x squared. A's kind of been replaced by x squared, right? And b has been replaced by, what's this, 16y squared? Oh no, if you take out the square from both, it becomes 4y. Nope, it's 16y squared. Because you can just take out, because what happened here was, wait, let me think this through. So you have x squared, and you have 16y squared to the power of 2. That b, no, it becomes 4. Oops. Yes, so b has actually been replaced by 4. That makes more sense. Because we, this is kind of what it looks like. So what we can do here, we can see this is kind of like a difference of squares in disguise. It doesn't look like a difference of squares at first, but once you kind of think about it, it breaks down into something that we're familiar with. So over here, let's kind of factor this first. So the first step is just following this form. We have A, which is x squared, plus B, which is 4y squared, times x squared minus 4y squared. Now, are we done? Well, don't get too hasty because this term can't be factored any further. It has plus sign, so we can't break this down anymore. But this term has a negative sign, which means this can also be a difference of squares. It does have a square. Now in this case, over here, let me change colors so it will make it look a bit neater. In this case, A has been replaced with x and B with 4y. Sorry, not 4y, 2y, gosh. 2 to the 2 squared is 4. Looks like a G. All right. So what we can do is we can actually break this even further. This becomes x plus 2y times x minus 2y. Don't forget, we still have to bring down this original binomial. But it hasn't changed. We just bring it down. Now, can we factor this any further? Well, whenever you see a positive sign, you know it's not going to be a difference of squares, so we can't factor that. But can we see a negative sign over here, right? So can we factor this? Well, unfortunately not, because it no longer is squared. So this is it. This is where we end. This is the final factored form. All right. Perfect square trinomials. So, what I found the definition in my notes was a trinomial formed from the product of two identical binomials. So kind of like a difference of squares because this is two identical binomials, but note how it says a trinomial, which means that once you expand it, it has to be a trinomial. And in a difference of squares, it is not. In a difference of squares, it's a binomial. So a perfect square trinomial is basically what happens when you replace the negative in a difference of squares with a positive. So let's take a look. Let me give you a few examples after. Let's work through this. Actually, no, I think I'll start with an example of what it looks like when you expand. So I want to think of one of a square trinomial off the top of my head. Let's say x plus 3, x plus 3 squared. So what x plus 3 squared looks like when we expand it is, let's first draw this out, because x plus 3 is multiplying itself, so I'm going to draw it out. Now we expand, or we use the FOIL method. First, x times x squared, outside, x times 3, which is 3x, then inside, 3 times x, which is also 3x, then last, which is 3 times 3, which is 9. Now, we're not finished here because we can actually combine these two like terms, which becomes x squared plus 6x plus 9. So this is what it looks like when we have a binomial squared, but it has a positive sign. That's why I said earlier that a difference of squares only has a negative sign, because positive signs will result in a trinomial. Over here, we can see something that kind of resembles this. Oops, I'm drawing all over the place. Kind of resembles this, except it's with a different number. So let's factor it. We can use the method of decomposition here, or we can kind of look at it from inspection, because, you know, grouping is kind of really takes a long time. But over here, notice how this is a perfect square, and this is a perfect square. The first term, x squared, is a perfect square. The last term, 25, is also a perfect square. 25 is equal to 5 squared. And notice how the middle term is 5 plus 5. So what we can be certain of is that this is a perfect square trinomial, which means there's a really easy way of solving this that doesn't require us having to factor or decompose it and like group. We can literally just figure out what the square of the last term is and then put it in this format. And so yeah, I've literally just factored it in under a minute. Under a minute. You can do this in less than a second. Yeah, so perfect square trinomials, keep an eye out for them. It makes your factoring a lot easier. And that's it. Oh my gosh, we finally finished this unit. This unit was definitely a long one. At school, you'd probably spend, I don't know, close to maybe almost even a month, depending how quickly or slowly your teacher moves. But teachers tend to spend more time on this because factoring is just so important. You'll be using it for the rest of your high school math career and even in other subjects as well. Super, super important concept. Yeah, so before we end off, let's go over some review. Over here, I've kind of drawn out a flow chart for you to help you remember how to factor polynomials. These are just kind of tips. So when you're given a polynomial, what you want to do first is look for a common factor. Remember what I said earlier? Whenever you see a polynomial, you want to take out the common factor because it makes your life so much easier. You don't have to deal with that pesky common factor when you're grouping or decomposing it later. And next, after you've taken out the common factor, you want to check if the polynomial expression is a binomial or a trinomial or a polynomial, so it has 4 terms. If it is a binomial, then you want to look for a difference of squares. If it doesn't have a difference of squares, then it can't be factored any further, so you just leave it like that. If it's a trinomial, then you want to check the a value, which is the first term in front of x squared. If the a value is equal to 1, so if it's not written, then you can factor it by just inspecting. So checking the last part, checking the last value and seeing which values add up to the middle value, the b value, and multiply to give you the c value. But if a isn't 1, so maybe a is like 3 or 5 or 100 or something, then you want to use the method of decomposition, where we broke down b into 2 integers that multiplied to give us ac and added to give us b. And then from there, after you've decomposed the b value, you wanted to group it. So yeah, that's how you factor those. And if it has 4 terms, then you can just do grouping right away. If it doesn't work while grouping, like if the values aren't the same, then you know that expression can't be factored, so you just leave it. And that's it. Let's do some practice. All right, so question A. Over here, I have a trinomial, so we want to remember step 1 was look for a common factor. Does this have a common factor? Well, 10x squared plus 17x plus 3. No, none of these have any values in common, factors in common. Like they're not all even, they don't have any x's in common, so we can't take out any factors, common factors. Step 2, so if it doesn't have a common factor, we want to check how many terms it has. This expression has 3 terms. It is a trinomial. So now we can take a look. Is the a value? The a value in this case is 10. Yeah, it's 10. So we know that the a value is not equal to 1, so we'll have to use the method of decomposition. So decomposition is just when we break down 17, the b value, into something that gives us AC. So AC in this case is equal to 30, which is because, 10 times 3. I don't know if you can read that. Let me rewrite it. AC is equal to 30. All right. And then we can break down which factors of 30 will give us 17. So let's kind of go in the middle. 3 times 10, would that give us 17? No, that only gives us 13. Let's try another one. 4, does 4 work? No. 5, does 5 work? 5 times 6, does that give us? No. This actually gives us a lower number. It equals 11, so we have to go in the other direction. So make 3, go in the other direction. Which make the left value a bit smaller and the right value a bit bigger. So 2 times 15, would that give us 17? Yes, it does. Cha-ching, it works. We can use 2 and 15 in our grouping. So let's go 2x plus 15x. And we bring down the 3. We bring down the 10x squared. All right, now let's group this. So 10x squared plus 2x, and then 15x plus 3. So in the first group, what common factor can we take out? Well, they're both even, so we can take out a 2, and we can also take out an x. We were left with 5x plus 1. In the second group, we can take out a 3, and that looks like it's about it. Yeah, that's it. So then we're left with 5x plus 1. Once again, these are the same, so we can just factor these. Factor the 5x plus 1 out, which will leave 2x plus 3. Yay, and this is our final answer. Underline it. Okay, moving on. Oh, I wrote A twice. This was supposed to say B. Let me just B. Okay, this is 4x squared plus 13x plus 3. It is a trinomial. Does it have a common factor? 4 squared? No, it doesn't have a common factor. It's not all even. And yeah, we can't take out anything. So let's move on. Trinomial. What is the a value? It is 4, which means that it's not equal to 1. And so we use the method of decomposition. Once again, we'll do the same thing that we did above. Let's break down 13. AC in this case is 4 times 3, which is 12. So what we can do is we can find factors of 12. Add up to 13. Oh, this one's pretty obvious. 1 times 12. That will definitely add up to 13. Check. What we can do here is write it down now. X squared plus 1x, which we can just ignore the 1. So just put x. We bring down the 3. I'm going to block this off. And bring down the 4x squared. Now we group it. I'm just rewriting it because that was really messy. Now we group it. In the first group, we can take out a 4x. And we're left with an x squared plus 3. The second group, we can't take out anything because x and 3 have nothing in common. So we'll just say we take out a 1. That leaves x plus 3. And, oh, did I put a square here? My bad. Let me erase that square, that was a typo. Yes, we can now take out an x plus 3 and be left with 4x plus 1. That's it. We finished factoring this. All right, moving on. We're almost done. These ones are relatively easy. The first one. Can we take out any common factors? Well, no, x squared and 49 don't have anything in common. Now, is this a binomial, a trinomial, or a polynomial with 4 terms? It is a binomial, so we want to look for a difference of squares. Now, is this a difference of squares? Well, we want to look at the last term. Is 49 a square of anything? Well, 49, hopefully you've memorized your multiplication tables. 49 is 7 squared, which means that this is indeed a difference of squares. So it will be easy to solve. You will come to love differences of squares as you take this unit because they're super quick to solve. Like you can just take a look and write it all down in a few seconds. Okay, next question. X squared plus 49. So this is kind of like the first one, except the sign of 49 is different. Now this sign makes all the difference because with this sign, we can no longer factor it at all. Like this is literally the factored form. So, yeah, don't make the mistake of thinking, oh, this is like a difference of squares. 49 is 7 squared. So I'm just going to put this in factored form, or not factored form. It's a perfect square, right? No, unfortunately, this is it. This is the most factored form, and you can't factor it any further. So let's move on. Finally, we have 8x squared minus 32. And once again, we go through our checklist. Step 1, look for a common factor. Now this actually has a common factor. They're both even, so we know that there's definitely 2, but we can actually take out an 8 from both of them because 32 divided by 8 is, what is 32 divided by 8? 4. So we can actually take out an 8 from both of them. 32 taking out an 8 from that leaves us with 4. Is this our final answer? No, let's always double check our work to see if it can be factored any further. This can actually be factored more because this is a difference of squares. Surprise! 4 is equal to 2 squared. So what we get is x plus 2 times x minus 2. And we can't forget our 8 from earlier. So this entire thing, this three has what, 3 things multiplying each other. This thing is our factored expression. And that's it. Thank you for joining us today. We're so glad to have students to teach. We're really glad to share our knowledge. And yeah, we wish you best of luck when you take this course at school. Next week, we're going to be starting a new unit called functions. Functions you may not have worked with before, so it will be a new concept.